Good morning. It's January 27th, and this is your daily brief in science. Here's everything you need to know. A sharper look at the cosmos. A new high-resolution map from the James Webb Space Telescope traces how dark matter warps light from background galaxies across the cosmos region near sextans. Webb's roughly 255 hours of first-year operations make this the largest survey to date and allow cross-checks with earlier Hubble data for consistency and new features. The map shows how dark matter clusters and links into filaments over cosmic time, supporting efforts to understand its fundamental nature within the Lambda-CDM framework. Researchers like Diana Sconamiglio of NASA's JPL and Rituparna Das of the Harvard-Smithsonian Center for Astrophysics emphasize dark matter's central role in cosmic origins and galaxy growth, with the cosmos field providing a key view of evolution through time. The study uses gravitational lensing to map dark matter relative to ordinary matter, covering the full 2-square-degree cosmos field and imaging by at least 15 telescopes. Webb and Hubble remain the primary instruments used in this region. The sextans-based cosmos region spans about 2 full moons in the sky and identifies nearly 800,000 galaxies, combining Webb data with observations from additional facilities to test dark matter behavior and gravity against standard models. A new 2026 guideline expands how acute ischemic stroke is treated, allowing more patients to receive endovascular thrombectomy and endorsing clot-dusting medicines like tenecteplase to speed up care. It opens EVT up to 24 hours after onset for select patients and broadens eligibility for posterior circulation strokes, even considering treatment for some with mild pre-existing disability within early time windows. Tenecteplase and alteplase are endorsed within 4.5 hours, with tenecteplase offering a single-dose option, and imaging may guide treatment up to 24 hours in certain cases. Imaging guidance prioritizes MRI with MRA when feasible, Connecticut as a fallback when MRI isn't timely, and ASPECTS scoring, where advanced perfusion imaging isn't available. The guideline is endorsed by major organizations and highlighted as an educational tool by the American Academy of Neurology. Quality improvement tools like Get with the Guidelines Stroke are promoted to monitor treatment times and outcomes, alongside telemedicine expansion and broader imaging access to improve care. Care coordination and outcome tracking via the Get with the Guidelines Stroke Registry plus telemedicine and transfer agreements aim to improve survival and reduce disability. The guideline calls for rapid, standardized care from pre-hospital recognition to discharge, endorsing imaging-based decision-making and simultaneous administration of clot-busting therapy and thrombectomy when appropriate. It stresses fast pre-hospital and in-hospital workflows, including aiming for a brain scan within about 25 minutes of arrival, with imaging-driven decisions potentially extending treatment windows. The guideline introduces the first detailed pediatric stroke recommendations, outlining diagnostic approaches and treatment options for children, including imaging strategies and possible use of IV alteplase and EVT in select cases. Pediatric guidance expands EVT eligibility and provides dedicated pediatric stroke guidance to standardize care across ages, emphasizing rapid MRI/MRA diagnosis and recognizing that adult tools may not apply to children. Pediatric recommendations stress rapid MRI/MRA, acknowledge limitations of adult screening tools for kids, and outline IV thrombolysis within 4.5 hours and mechanical thrombectomy for select pediatric cases. A 40-million-year-old ant fossil has been identified inside Baltic amber once owned by Goethe, using 3-dimensional imaging to reveal details not visible to the naked eye. Goethe's amber collection includes about 40 pieces, with 3 documented inclusions to date: a midge, a cranefly, and this ant, all identified through modern imaging techniques. Synchrotron micro-CT at DESY produced 3-dimensional images of the insect inclusions, enabling precise study of its head and thorax interiors. Interactive 3D models of the amber inclusions are now available online to help researchers identify and compare similar fossils. A full preparation and 3-dimensional reconstruction of the specimen have been completed and published online, aiding global researchers in recognizing related fossils. The amber offers unprecedented interior views, detailing structures in the ant's head and thorax that are preserved exceptionally well. Despite not being visible with the naked eye, The specimen has been identified as the extinct species Catenobethelus guaperti through these imaging techniques. Based on similarities to Leometopum, researchers infer the ant likely built large nests in trees, explaining why related ants are commonly found in amber. The ant is described in greater detail than before, thanks to high preservation of its head and thorax within the Baltic amber. Goethe's historic interest in amber connects optics and color study to the contemporary scientific value of his collection. A 3D reconstruction of the ant has been created to facilitate identification and comparison of future fossils, enhancing understanding of its morphology and evolutionary relationships. The 3D model is publicly accessible on Sketchfab, and the findings are published in Scientific Reports, 2026, with DOI 10.1038/S4159826-3600004-4. Dragonfly, a car-sized rotorcraft destined for Saturn's moon Titan, is advancing through aerodynamic testing and ground validation as the team targets a 2028 launch and a 2034 arrival. Recent campaigns at NASA Langley's Transonic Dynamics Tunnel are assessing rotor performance under Titan-like conditions, focusing on stress, vibration, and aerodynamics to ensure reliable operation during entry and descent. Lead rotor engineer Felipe Ruiz and APL emphasize precise manufacturing and rigorous ground testing to minimize risk in Titan's atmosphere. Construction of Dragonfly's rotors began in late 2024 using water-jet cutting and iterative fabrication, with full-scale spin tests completed before transport to Langley for further evaluation. Over 5 weeks in 2025, researchers evaluated rotor performance under conditions simulating Titan, examining rotor stress, vibration effects, and aerodynamics. Langley's Transonic Dynamics Tunnel plays a critical role in validating aeroelastic behavior prior to flight. Dragonfly represents broad collaboration across Johns Hopkins, APL, Penn State, Sikorsky, NASA Langley, multiple NASA centers, universities, and international space agencies as part of NASA's New Frontiers program. The mission will explore diverse Titan environments, including organic dunes and a crater that may have hosted liquid water and organics, with the goal of flying to multiple locations to study varied conditions. Rotors will undergo fatigue and cryogenic tests at Titan-like temperatures, about -290 degrees Fahrenheit, -178 degrees Celsius, before final production for flight. And the spacecraft is designed and built at APL in Laurel, Maryland, with international contributions. A new chapter in Twisted Graphene begins with a finding. In Twisted Monolayer Trilayer Graphene, researchers demonstrated states with churn number absolute value 3 at a specific filling, and the sign of that churn number can be flipped by electrostatic doping or a displacement field. In Twisted Bernal Bilayer Rhombohedral Tetralayer Graphene, a displacement field-driven topological phase transition occurs between quantum anomalous Hall states with C equals 3 and C equals 4 at a particular filling. The system also shows near-zero Hall resistance and a hysteretic anomalous Hall effect, indicating broken symmetries and fully polarized charge carriers. Residual disorder and imperfect contacts limit perfect quantization, with future work aiming to reach higher churn numbers and to explore proximity-induced superconductivity for chiral Majorana edge modes. Raman mapping confirms rhombohedral domains survive encapsulation, supporting the structural basis for the observed phenomena. Spin-valley locking from Ising spin-orbit coupling enables valley control through the Valley-Zeeman effect, affecting band overlap and inversion in valley-polarized bands. Future directions include mapping the phase diagram across spin-orbit coupling strengths and twist angles, and exploring proximate anisotropic spin-orbit coupling with low-symmetry two-dimensional materials, as well as investigating correlated electron hole states such as excitonic insulators and viscous Dirac fluids. Optimal proximity-induced spin-orbit coupling effects arise at misalignment angles between graphene and tungsten diselenide around 15 to 20 degrees, with devices showing angles near 15 and 18 degrees, highlighting alignment sensitivity. Proximity-induced spin-orbit coupling on the MEV scale, combined with strong correlations from surface flat bands, leads to spontaneous symmetry breaking and novel electronic states. Twisted rhombohedral graphene is positioned as a versatile platform for high Chern number topological materials and exotic quantum transport, with implications for low-power electronics and multi-channel devices. The broader study frames rhombohedral multilayer graphene as a platform to explore the interplay of strong correlations, topology, and spin-orbit coupling, with potential impacts on spintronics and quantum computing. Dual-gate structures enable independent tuning of carrier density and displacement field, allowing precise mapping of phase behavior including insulating states. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.